This video looks at decision tree analysis. Decision trees are a quantitative risk analysis technique. They allow organizations to structure their costs and benefits of decisions based on alternatives. Now, these alternatives are determined by certain conditions, and the conditions you can think of it as states that arise due to various probabilities. So, in a decision tree analysis, as the name implies, we have to construct the tree, and that's what I'll be teaching you in this video. Now, a couple of important points that we have to note before we start constructing the tree. Point number one is that there's different symbols in the tree, and we have to understand what these symbols mean. So the first symbol that we're going to start off with is this rectangular symbol, or the square, and that's your decision node. And then the second symbol is the circle, and that denotes a chance node in the tree. So that links to your conditions and the states. And then the final symbol is the triangular symbol, and that denotes the endpoint. Okay, so the best way of looking at how the tree is constructed is by actually doing an example. So I've got an example over here. Now suppose that you had two subcontractors, Subcontractor A and Subcontractor B, and you had a job that required the use of one of these subcontractors. Let's assume concrete pouring. Now I've got a set of conditions for each of these subcontractors. So the first condition is the operation time, when these subcontractors can operate on site. So I've got morning and afternoon. And that's the operating condition, operating time condition, I should say. And then I've got some conditions that are related to the efficiency of these subcontractors. So full efficiency, half efficiency, and low efficiency. And these are my efficiency conditions. And finally, I've got my accuracy, if you like, conditions. So mistake and no mistake. So these are all conditions, characteristics that are related to the subcontractors that I have a choice of utilizing on my construction site. Now, an organization, and that's a simplified example, an organization would have several alternatives. So in this case, I only have two alternatives, one and two, Subcontractor A and Subcontractor B, but typically organizations would have several alternatives. I'm just using two alternatives in this example to demonstrate how the decision tree works. So these final conditions, accuracy of work, if you like, the conditions. Now for each set of these conditions, I've got a probability associated with each of the subcontractors. So 0.5, 0.5, and then 0.5, 0.5, not relevant, 0.8, 0.2, not relevant, not relevant, 0.6, 0.4, 0.1, 0.5, and 0.4. So these are numbers that organizations would come up with. Now, what do these numbers tell me? Well, for subcontractor A, the probability that the the subcontractor would operate on site in the morning is 0.5. The probability that they would choose to operate in the afternoon is 0.5. So over here, we're assuming that there is a risk that we can't control the time that the subcontractor chooses to show up on site. For subcontractor B, there's a 0.6 chance that they would rock up on site in the morning, and there's a 0.4 chance that they would rock up in the afternoon. Notice that both of these values, they have to add up to 1. And then it's the same for the other conditions. So for the efficiency conditions, so 0.5 at full efficiency, the probability 0.5 that they would operate at half efficiency. That's for subcontractor A. For subcontractor B, I've got 3 efficiencies. So 3 possibilities of efficiencies. 0.1, probability of 0.1 for full efficiency, probability of 0.5 for half efficiency, and then there's a low efficiency of 0.4, probability of 0.4. So as I said, these are numbers that organizations would come up with, and they'd be based on the risk of these conditions. So how do we construct the decision tree? Well, the first thing that we have to do, based on the information provided, is that we have to start off with R square, the decision node. So I have 2 options. Option subcontractor A and subcontractor B. I don't need to make a choice. And then a circular node. And that denotes that there has to be a choice that is made. So it's a chance node. And whenever I have a chance node, it means that there is a choice that I have to make. So the first choice is related to whether the operation is going to be in the morning or in the afternoon. Now, I don't control this, so it's based on probabilities. So morning, this is the first branch, and then I have afternoon, and that's the second chance out of this node. Now for the morning, we said that the probability was 0.5, the afternoon was 0.5 for subcontractor A. Now for the afternoon, it happened to be that there's other conditions that would arise, so I need another chance node, and I've got several branches. So the first one, actually 2 branches, full capacity or full efficiency. I should say full efficiency, and then half efficiency. Again, I don't control the efficiencies, that's why there's probabilities. So my probability, the organization has estimated that at full efficiency that subcontractor is going to operate 0.5, and the probability that they would operate at half efficiency is again 0.5. And then for that half efficiency, I've got another chance node, so another state. So whether the subcontractor will be subjected to a big mistake in their work, or whether they produce their work without mistake, no mistake or error. And the chance for that mistake is 0.8, and the chance for no mistake is 0.2. And here it ends, so I've got to put a triangle. That's to denote that this is the end. This over here, it ends, so no more states. And this happens to end based on the case study as well, so no more states. Okay, so that's the first half of the tree completed for subcontractor A. Let me move on to subcontractor B. So for subcontractor B, again, it's the same sort of concept. I have my chance node, and it's to denote whether they will rock up in the afternoon or in the morning. So the chance that they would rock up in the morning is 0.6. Morning, that's 0.6. And then the chance that they would rock up in the afternoon is 0.4. All right, So I have nothing else after this morning branch, so that's why I would have a triangle at the end, just to denote that that's the end of the branch. For the afternoon, however, I've got several states that are possible. So full capacity or full efficiency, so that the subcontractor B would operate at full efficiency, half efficiency, and low efficiency. Now these are again probabilities are based on probabilities. So full efficiency, the probability is 0.1. Half efficiency, the probability is 0.5 based on the scenario given. And then the low efficiency one is given as 0.4. Okay. And for subcontractor B, based on their history, in that scenario, they happen to be very well skilled, so there's no mistakes, and each branch would end. So I have a triangle at the end of each branch. All right, so that's the decision tree that I have. Notice that for subcontractor A, they're prone to mistake, so that's why I have this sort of third condition. I can actually label these chance nodes. So I've got one here. That one would be the same because I've got morning and afternoon as well coming out of it. Full efficiency, half efficiency, that would be the second one. That's the third sort of type, because here in the third type I've got low efficiency as well for subcontractor B, and then I have the fourth one at the end over here. Now in that scenario, the organization had undertaken a rigorous analysis and then found that the main objective that they're focusing on is delay. So let's add a delay column here at the end, and delay is in terms of time, so how long the delay is with respect to the project, finalizing the project, so the delay in completing that project. For each endpoint, the organization calculates the following delays. So there's 8 days. So the delays are measured in days. 8 days for that first endpoint, and then 0, 28, 12, 6, 16, 22, and 28. So that's the analysis, that's the preliminary analysis, if you like, that the organization had undertaken. And now the question is, should this construction organization go with subcontractor A, or should they choose subcontractor B? Okay, so that's the whole purpose of the decision tree analysis that we will conduct. So all this information is given, so it's already conducted by the organization, an analysis, a preliminary analysis, and it came up with these numbers. And now we have to implement the expected monetary value approach, and I'll show you how to do that in a second. So you'd always, with a decision tree, you'd always start at the end. So, and the end is over here at that point. All right, let's start at the end, and let us start with the 28 delays. So usually it start with at the end with the node that has the most sort of the lowest level of the hierarchy. In that case, it's node number 4 over here, so 28. So as I said, it's based on EMV, expected monetary value. So what I need to do is multiply 28 by the probability of a mistake 0.8 plus 12 multiplied by 0.2, and then that would give me a value for that node. So let me do the calculation here. Maybe let me just change the color of the font. So I've got 28 multiplied by 0.8 plus 12 multiplied by 0.2. And the EMV at this node, at node number 4, that would be equal to 24.8. 24.8. Okay, all right. Let's move to the second level in the hierarchy of these nodes, and that's node number 2. So I know that now that for node number 2, there's the value, the expected value at node number 4, 24.8, and then I have the other branch. So that's the 0 multiplied by the 0.5. So 0 multiplied by the 0.5 plus the 24.8, which we calculated in the previous step, multiplied by the 0.5. These are brackets, so, and the answer at node 2, that should be equal to an EMV of 12.4. Okay, and then finally, that's sort of at the upper level of the hierarchy, node number 1. So for node number 1, 2 branches, 0.5 multiplied by 12.4, and then I've got the upper branch to 0.5 multiplied by the 8. So it's 0.5 multiplied by the 8, that's the upper branch, and 0.5 probability of the lower branch multiplied by the 12.4. So the answer that you would get is 10.2, and that's for subcontractor A. 10.2 expected monetary value is 10.2. So that's the average or the expected delay for subcontractor A, 10.2. Now, when you do these calculations, remember that we always start from the end, and we trace it back to the node. So for node number 1, for instance, I had to trace it back for the branches. For this branch, it was towards the very end of the tree, trace it back. So we've got to multiply it by the respective probability 0.5. For the lower branch, we trace it back until we hit a node, and that happens to be node 2. So we already calculated 12.4, multiply it by the respective probability of 0.5, and that would give us the EMV value for that specific node that we're looking at. Okay, so we've done the calculation for the top part. Let's do it for the bottom part now. So for the bottom part, which is subcontractor B, again, start at the end, and let me start at node 3. That's the sort of the node at the lowest level of the hierarchy for subcontractor B. So I've got 3 branches. So the first branch, that's 0.1 multiplied by 16, 0.1 multiplied by 16, plus 0.5 multiplied by 22, plus 0.4, that's the third branch, multiplied by 28. And the answer that you should get is 23.8. Okay, so the expected value at node number 3 is 23.8. Now let's move backwards, and that's the end of the hierarchy over here. That's the final node. That's the upper level of the hierarchy, if you like, moving backwards. So for that node, for the first branch, it's 0.6 multiplied by 6. So 0.6 multiplied by 6 plus 0.4 multiplied by, if we trace back, we arrive at a node. And for that node, remember, we calculated the value as 23.8. So it's 0.4 multiplied by 23.8. And the answer that you should get is 13.12. Let me double check. So 0.4, 23.8. Yes, 13.12. Okay, so that's for subcontractor B. So what do I have now? I've got 2 values that I need to compare. So this value that I got for subcontractor A, and then this value that I got for subcontractor B. What's the whole purpose of this analysis? The whole purpose of this analysis is to make a choice between subcontractor A and subcontractor B based on the subcontractor that would impact my project the least. And I said that for us, the objective is delay. So the one that has the least delay is subcontractor A. And as a result, the company or the organization should choose subcontractor A based on the scenario and the probabilities that were given in this instance.